install 3D platformer video game using two pieces of software, primarily Godot, a free and open source game engine where you can build and code your own video games, and Blender, a free and open source 3D creation suite for modeling, texturing, and animating 3D models for your games. This course is meant for the absolute beginner. If I can teach this to middle schoolers, well, I can teach it to you. Now, if you already have even a little experience using Blender, you'll be able to take this project even further. Otherwise, I'll be guiding you step by step through each phase of building and programming this project, including creating a new project in Godot and starting a game level, adding a camera and a light into the game level, and we'll add a simple character object. We'll start with a cube, programmed to move by pressing the arrow keys on the keyboard. We'll be breaking down and covering what I consider to be the top 8 programming concepts beginner programmers need to know to get started coding, as we customize the movement of our character using code, create collectible objects, coins, that disappear when you collide with them, make your character jump and tilt to align with the floor that he's standing on, make the camera follow and be able to rotate around the character, create keyframed animations and trigger them to switch and play with code. We're going to create enemies that turn around at walls and edges. We're going to make moving platforms using tweens, a heads-up display on screen to show how many coins have been collected, menu screens with text, images, and coded buttons. And because this is a 3D game, we'll be using Blender to create a few of our own custom game assets, including a coin model, as well as textured blocks that we can easily use to construct our game level. Lastly, we'll finish this project off by exporting to a standalone Windows program, as well as publishing our game to a popular indie website, itch.io, where our game will be playable right in the web browser. For this course, I'll be providing you with all the assets you'll need to complete this project right alongside me. I can't wait for you to join me in creating this 3D platformer game and entering the world of game dev. To get started, you'll need to install both Godot and Blender. If you're using a laptop, I also highly recommend having a real mouse rather than having a trackpad or something else. I recommend getting both programs from the official sources. Godot from godotengine.org. We'll go up to downloads here, and I recommend getting the latest version, at least 4.0. I'm going to download the Windows Standard 64-bit version, and that's what will work best with my computer. And it's a surprisingly small download at just about 51 megabytes. It's a zip file downloaded here to my downloads folder, which I need to unzip. So in Windows, I'll right-click on it, and I'll say Extract All. Now, Godot is a bit of a funny program in that in Windows, it doesn't need to be installed. It's just a standalone program, an exe file. I'll go ahead and drag it to my desktop, where I'll keep it throughout this course. Please note that in the next lessons of this course, I was actually using Godot 4.0 before I upgraded to 4.1. If you're using 4.2 or 4.3 or later, there should be just minimal differences, okay? You can get Blender from blender.org. The latest version of Blender for me is 3.6, though any recent version of Blender 3 or 4, when available, should be fine. I'll go up to Download, where I'll click to download the version it recommends. In Windows, there is an installation process to go through to install Blender, but it's very straightforward. Once installed, you should find Blender under your Start menu. For me, it's right here. Let's go ahead and get started. Alright, let's go ahead and jump in and start using the Godot game engine. In this video, I'll be showing you how to create a new game project in Godot, and once we're in the Godot editor, I'll be showing you around its interface so you're not too overwhelmed with everything that's going on your screen inside of Godot. And lastly, in this video, we're going to create our very own 3D scene, which will be the main level in our game. So let's go ahead and jump in. On my desktop, I have the Godot game engine program right here. When I double click on it, if I'm using a Windows-based computer, which I am right now, Windows might actually pop up with a warning about your firewall settings. If that's the case for you, you can make your own best judgment about if you want to grant Godot the ability to access your network and the internet. I'll leave that up to you. It actually doesn't really matter because we're not going to be using Godot to make multiplayer online games in this video, so you can go ahead and press cancel or no or yes. It's up to you. When Godot first launches, you actually don't see Godot's editor. Instead, you see Godot's project manager, which is essentially a list of all of your current projects. If, like me, and you probably are, you do not have any projects that you've made with Godot yet, it'll warn you, or it'll let you know that you currently don't have any projects. And it'll ask you, would you like to explore the official example projects in the asset library? We're going to go ahead and just say no, cancel, because we want to create our project right away. To do that, I'll press new project right here, and Godot will pop up with a window that lets me choose my project name and also where I want to save my project on my computer. Now, here's a warning for you. Godot needs to have an empty folder for every new project that you create. On your computer, in my case, on my desktop, I'm going to create a new empty folder right now for my game project with my game project name. And so to do that, what I'll do is I'll press Browse and navigate on my computer. This is all of the files and the folders in my Documents folder. You can see that right up here on my computer. I don't want to be here. My Documents folder is obviously not empty, so I can't create a new project here because you need a new empty folder for that. So I'm going to press the up button right here to go up to my user folder where I have my desktop folder. And on my desktop folder, I'm going to create a new empty folder in just a moment. Just in case you want to save to somewhere else on your computer, like another hard drive or a USB drive that you have plugged in, you can navigate to different drives right here with different letters on a Windows-based computer, okay? So on my desktop, I'm going to press Select Current Folder, and when I do that, it's still going to warn me that I can't save here because my desktop is not empty, but what I can do is I can create a new folder with my project name right here. So I'm going to type in 3D platformer game, just like that, and I will press create new folder, and it will make it right here on my desktop. So create folder, and the very last thing we have to do is select our game engine renderer. If you're not familiar with what this term means, a renderer in 3D or game engine software means how it will draw the visual fidelity of your game. In other words, this controls how your game will look, how advanced it'll look, and if it's compatible, if your game is compatible with different types of platforms, including mobile platforms like Android and iOS phones, or if you even want to put your game on the internet, like it's playable in a web browser, you can select any one of these options. Don't worry, you can change your mind later if you want, so I'll just leave mine on Forward Plus, which will give me access to the best graphics that Godot can create. So let's go ahead and press Create and Edit. The project manager will disappear and the Godot game engine itself will load. When the game engine loads, it's a little bit intimidating and a little bit bare bones at the same time. The main part of Godot's interface in the middle of the screen is called the workspace. And the workspace has 4 different pages, if you will. Up here at the top, you can switch between working on a 2D interface in your game. This might be for a 2D game or for a game menu screen. There is the 3D workspace page, which has access to, of course, viewing your 3D space and your 3D levels. Next up is the script workspace, where you do all your coding and programming. In this course, we'll be spending a lot of time here coding in GDScript, of course. And lastly, there is the asset library, which is kind of like a store that you can access right inside of Godot that gives you access to other people's files, projects, and resources. We won't spend any time here at all. We'll be spending most of our time between the first 3 different workspaces right here. On the sides of Godot's interface are what are called docs. And docs are basically where you add everything and change all of the settings in your 3D environment. So they are actually arguably the most important part of Godot's interface. Up on the top left of Godot is what's called the scene doc. And this scene doc is the most important part of Godot, I would argue, because it's where you add what are called nodes. Nodes in Godot are the building block for everything in your game. All objects in your game, all sounds in your game, they are all built here. And if you press the little plus button right under the word scene, you will get access to all the different types of nodes that Godot has for you to add. Now, these nodes, again, are building blocks of a game, and they are structured in this window in what's called a node tree. A tree structure is where you have a parent node that you can expand by clicking the little arrow next to the name and the icon, and you can expand further branches of this tree and explore all the different categories of different nodes. Nodes are, again, every part of your game, so you should recognize some words here that you could see being in a game. If you want to have animation in your game, you might add an animation player node. If you want to add sound or audio into a game, like music, you would add an audio stream player node. There is a whole category for 3D objects in your game. They are all under this Node 3D branch, and if you expand it out, you can see cameras and grid maps and audio listeners and different types of collision objects and physics bodies, including one that we're going to be using a whole lot called a character body 3D. There are collision polygons, light probes, paths, skeletons, everything you can imagine that makes up your game is a node inside of Godot. The very first node that we're going to add into our game level, and that's what we're going to be doing over in the scene dock, is creating our own tree of different nodes, is the basic, I'll go and press plus again, is the very first red node that you can see, which will be the basis or root node of our game level. The very first node that we add is going to be the node 3D node. I don't actually have to go into this pop-up window to add it though. If I go ahead and press X to close this window, all I have to do to add that is press 3D scene. It's so common to start off your scene this way. They have buttons for you here. So 3D scene will create our first node, our root node in our 3D environment, establishing this scene as a 3D scene. Speaking of which, in the middle of our screen is our workspace area, which shows us our 3D environment. And if you've never worked in a 3D animation program before or a 3D game engine before, there are 3 things you need to know about how to navigate in this 3D space before we move any more forward in this lesson. The first thing you need to know about how to navigate in this 3D environment is how to zoom in and out. And that is simply, if you have a mouse with a mouse wheel, if you put your mouse cursor in the 3D environment window and you scroll up and down, if you scroll up, generally that will zoom in, and if you scroll down, generally that will zoom out. Be careful about zooming too far out though, because you might in fact lose track of where you are in your scene. Things that are quite small or in fact normal size in your environment might disappear, so make sure you're keeping within a range where you can see. Once we add objects into our game level, you can still see them there, okay? The next thing you need to know how to do in your 3D environment is how to orbit. Orbiting in Godot means to spin your view around to look at your scene from different perspectives. To do this, press and hold your mouse wheel down like a button, and while you're pressing down your mouse wheel, move your mouse around. When you do this, well, you'll be able to see your scene from the front, from the back, from the bottom, from the top. Take a few moments and familiarize with yourself with how to do this and get comfortable looking at your scene from any possible direction, either zoomed out or zoomed in, okay? If you don't have a mouse with a mouse wheel that pushes in like most do, you might find it more easy to go up to this little on-screen gizmo with the different axes and simply click and hold and drag in this little circular area to do the same thing, which is called orbiting, okay? The third thing you should know how to do is how to pan around your scene. Think of how you would take a panoramic photograph with your cell phone camera. In other words, you would want to look all the way from the left of your scene to the right of your scene, or perhaps all the way from the bottom to the top. If you orbit in your 3D environment, but instead of just pressing the mouse wheel down, you also first hold the shift key on your keyboard, and while you're holding shift, you then orbit, well, it does what's called panning. Panning can be from left to right, so you can see from left to right in your environment, or it can be up and down. So be familiar with how to zoom in and out, how to orbit, and how to pan with the shift and orbit middle mouse button. There we go. Before we move forward in this lesson and create a few elements of our 3D scene and save this scene as our game level for the rest of this project, there are 2 more docks on the screen right now that I want you to know about. And those are on the bottom left of your screen is what's called the file system dock. This file system dock shows you all the files that you currently have in your project folder. If I go ahead and minimize Godot, you can see on my desktop it is my project folder, which just a few moments ago was empty, but as soon as we created our game project, Godot actually put some contents in this folder, including a very important file called project.godot, which is our actual game project that Godot can open. We have an icon.svg, scalable vector graphics image file. We have a few other settings and attribute files, as well as a .godot folder, which has even more settings, files, and other folders in it. Once you've made a Godot project, please do not edit or rename or attempt to reorganize anything in this project folder. Of course, you can add things into the project folder, like 3D models, sprites, fonts, images, things you want in your game, but these need to be here, okay? The last doc that I want you to know about in this video is over on the entire right side of your screen. It is called the Inspector. The Inspector is where you can see properties and change properties of anything that you currently have selected in your game. Specifically, nodes that you currently have in your game level. Right now, my game level isn't very much. In fact, there's only one node. So if I go over to the left side of my screen and select that node 2B, our scene's root node, I can then go over to the other side of my screen into the Inspector and see all of its properties. You can see its name up here at the top, Node 3D. So once you have many nodes in your node tree over in the scene dock, well, you can select any one of these properties over here on the right. The Node 3D node has some basic properties. If I expand out their sections, there's a transform section, so I can change the location and rotation and scale of my 3D world. Please don't change any of these settings for any amount of time, unless you want to change them back. There is a section called visibility, and yes, our world is visible. If I turn it off and on, well, that would actually hide game objects from the editor's view and when I play my game. There are other sections here that we're not going to use very much called process and editor description, but depending on what kind of object you have selected, depending on what kind of node you have selected, there will be different properties for those kinds of objects. Speaking of objects and nodes, we're going to add one more object into our scene, and that is one that is necessary in order for us to see our game level. Before we do that, let's go ahead and actually save our scene. Before I save, I'm going to rename this node simply by double-clicking on its name right here, Node 3D. I'm going to call this level, its root node therefore, Level 1. When you name nodes, I'm going to strongly suggest that you do not put any spaces or special characters in their names, and that's because you'll be referring to those nodes sometimes in code, and typically you don't put spaces in the names of things in any coding that you ever do, okay? So level 1, capital L, no space. I'll press enter to make that final. If I want to save this scene, of course, I can just go up to the scene menu and say save scene, or I could press, of course, Control S. If I click on save scene, it'll ask me, because I've never saved this scene before, where I want to save it and what I want to call this file. A scene in Godot is a file that ends with .tscn. I kind of think of the T as silent, so scene, if you will. It'll name it with the same name that you gave your root node in the scene, but it might put underscores when it recognizes different words and numbers. That's okay. I will go ahead and simply press save, and because the path where I'm saving is my res, which is the same as my scene project folder, I'll press save, and it'll be right here, level1.tscn in my file system doc. If I want to try playing this level or running it like I would run my game, I could go up and press the play button, but I would suggest that you don't, because when you press play, it's going to ask you to set the default scene in your entire game project. We're not there yet. So instead, I'm simply going to press the play scene or play the current active scene button right here. If I press it, Godot will launch and I will see my game run. There it is, and our game looks really boring. Why am I not seeing the same game world with my sky and my brown floor? Instead, I'm just seeing gray. Well, that's for a few reasons. Number one, in order to see your world, you need to have a camera in your game level. So right now, let's actually go into our scene dock. In order to add a child node to our root node, just like if I were to press the plus button, all of the nodes in this tree structure have a parent, and anything that's underneath that you can collapse into that node is a child of that node. This white circle here is the root node or the parent node of all other nodes in Godot. And when you have a child of this node that is itself a parent, of other nodes that is called a branch. We have to create the same sort of a tree structure with parents and children and branches with their own children in our scene. So before you ever add any nodes, you should always select the node that you want to be the parent of what you are about to add. So I'll click on the little icon for level 1 and I'll press plus, and I'm going to do a little search here for camera. And if I just type in camera, of course, if I don't want to search, I can find the camera 3D for a 3D scene under node 3D, and then it's right here. It's called camera 3D. In fact, there are different types of cameras, but we'll just select that one, and I'll press create. When you do that, it will add a child node to the node that you just had selected, which means that we have a camera 3D in our level 1. Our camera 3D, if I go ahead and zoom way in, you will see it right here. And of course, you can use these controls on screen. They are called gizmos to move and rotate the camera. We don't have anything to look at with our camera, but if I just move the camera back by grabbing the Z blue movement or transform handle and then the Y transform to move it up, I can have my camera a little bit back looking at the origin of my scene where the Y, Z, and X axes in my world meet. Let's go ahead and see what this looks like if I press Control S to save, and I can go up and press the play scene button. My game will launch, and at least now I can see through my camera at the middle of my scene, and that is as far as we're going to get in this lesson. In this lesson, we have covered how to create a new game project in Godot. We've done a quick overview of the different parts of the Godot editor interface, including how to add nodes to create a game level, including a camera, and before that, a root node 3D. And we have saved our scene and tried running our game level. It's worked, but we don't have anything in our game environment yet, not even a sky or an environment, as it were. We'll be adding those in the next lessons in this course, but that'll be it for this one. I'll see you in the next one. Bye-bye.
Old Spice Gin Super Hydration Body Wash with 24/7 moisturization and vitamin B3.
Alright, in this lesson we're going to begin constructing our 3D game level. What that means is, in this video, we're going to begin constructing 3D physical objects. Objects that you can see, and more importantly, objects that other objects can bump into. In this lesson, we're going to be adding a floor into our game level, which is a 3D solid object that you can see. And we're going to learn how to create reusable objects, which are going to be falling blocks that we can create as many of as we want in our game level. And the neat things about these falling blocks is that they can actually fall with gravity using Godot's built-in physics engine, and they can bump into each other and into other objects like our ground in our game level. Let's go ahead and jump in. On my desktop here, I have the Godot game engine icon. If I go ahead and open up Godot, you can see that I have my project listed here. Just in case you're not aware, and I'll cover this right at the beginning of this course, if you open up the Godot editor and you do not see your project listed, I'm going to go ahead and select my game project and press remove and remove. What you can do is simply take your game project folder right here and drag it into this project manager and let go, and it will add itself into the list of projects you can go ahead and double click on to open. You can also open up that project folder and find the file that ends with .godot. That file will probably be called project.godot, and if you find that file, you can also drag it specifically into your project manager, and it'll show up in this list just like it did before for me. Okay, let's go ahead and double click on the project to open it up. As of the last lesson in this course, we made a level 1 game scene in the Godot editor. In this level 1, we have a root node as well as a camera. To add a physical object, a floor, into our game level, we have to begin by adding a type of node into our scene. Recall that in the last video, the way that we add objects into our game is by selecting the root node of our current scene. And by the way, If you don't have your scene currently open, I'll close mine. You can find it called level1.tscn down here in the files for the doc on the bottom left of the Godot editor. I'll go ahead and double click on it to open it up. If I select the root node of my scene, I can then add objects into my game level. I'm going to select that root node and press plus because the type of object that we're going to add for a floor is considered a physics object in Godot. It's a physics object because it exists in a world with physics, and that means that other objects like your character, like falling blocks, can collide with it. So if I find the section, the branch of this node tree called node 3D, and I expand that out, and then I find a section here called collision object 3D, and I'll expand that branch out, and then physics body 3D, and expand that section out. Don't worry if you're not following along with me here. I'll go ahead and show you how to search for this in just a moment. But if I keep digging into physics body 3D, I open that branch up. There are types of physical objects here, including one called a static body 3D. This is actually a branch on its own, and I could expand it out and find animatable body 3D, but I'm just going to stick with the one called static body. Static in this case means not moving, which is what we want our floor to not do. We don't want our floor to move. So I'm going to select that type of node. If you just want to search for static and find that exact node, it's a red one. It's called static body 3D, and I'll double click on it to add it into my game level. There it is. It should be a direct child. That means there's a direct line indented just once here below my game level because I had my level 1 root node selected when I pressed the plus and added this node in the first place. So now what I'll do here is name this node. If I double click on its name, I can select the text here, and I'm going to name this floor and press enter. So now that static body 2D is my floor. However, you'll notice that in the scene, in your actual 3D viewport, you don't see anything. You have it selected, and you have these control gizmos on your screen that you can move the floor around with. Don't do that though. You could, but we can't see anything right now because it turns out there's an error in my scene. If I go ahead and click on this little warning here, it tells me what's wrong. It says this node has no shape, so it can't collide or interact with other objects. Consider adding a collision shape 3D or collision polygon 3D as a child of it to define its shape. That's what's wrong. We have a physics object, but it doesn't know what it should look like, and it doesn't know what its boundaries are. In other words, what its collision surface is, where its force field is, where other objects will collide with it. So I'm going to select that floor, and we're going to add 2 children nodes to it. When you construct an object in Godot, it's very common that you combine multiple nodes together in a little mini hierarchy so that you have an object with children, and the children give that object more information. In this case, I'm going to select the floor node that I just added, and I'm going to press the plus button. I'm going to add a node, and I'll see if I can find it manually. Here, I'll clear out my search. It should be under node 3D. It should be under visual instance. What we're looking for here is under geometry instance, perhaps. Yes, it is called mesh instance 3D. We want to add a 3D mesh object, like with polygons, into the scene, which is going to be a cube for our floor. We're going to stretch that floor out, but it's going to be a basic cube. If you don't want to find it in this node tree structure, you can simply search for mesh, and then I'll find it here. Mesh instance 3D is what you want. I'll double click on it, and if you did it right, you'll see that it's now a child of the floor because I just had my floor selected and we added it. Okay? This mesh instance doesn't look like anything either until we select it and go over to the inspector on the right side of the Godot editor. The inspector will show you properties of the current node that you have selected. So if I have a mesh instance selected, well, I can choose. You can see the first property here of that mesh is empty. Well, the mesh doesn't know what its polygons should be, essentially. So I'm going to click right next to empty here, and I can choose one of the default primitive types of meshes that Godot itself knows how to build for you. I'm going to select, after clicking this little arrow right here, a new box mesh. When I do that, it makes a new resource, in other words, a primitive type of data that Godot knows how to make right inside of Godot. In this case, now we have a little cube, a box in our game level. If I want to make this box look more like a floor, larger, but maybe not as tall, what I can do is click on this resource to expand it out. You can click on the little picture of the cube to expand its properties, the resource properties. and contract it, but I'll expand it, and I can now type in values for the size that I want this cube to be. I want the floor to be quite big, so I'm going to type in maybe 10 meters, and I'll press tab. By 0.5, remember that y, the y-axis is up and down in Godot, so if I type in 0.5 for y, and then press tab to go to the next data input slot here, it'll make it shorter, half as tall as it was before, and I'll type 10 into the z-axis and press tab. So I have a 10 by 0.5 by 10 size cube. There we go. Is that enough to make a proper floor? Well, it turns out no. This floor, it still has that warning here. It's telling us that it needs a collision shape in order for the physical object, the static body 3D, to know where its force field is, where other objects will collide with it, like its force field. So I'm going to select that floor again, not the mesh instance, but the floor, because I need to add a second child to it. I'm going to select floor and press plus. I'm going to search for, I'll clear out my search, for what's called a collision shape 3D. Where do I find this? Well, if I dig into the branch called Node 3D, it is right here. It's called Collision Shape 3D. Of course, you can search for that. I'll type in COLL, and I'll narrow my search down to that, and Collision Shape 3D is right here. I'll go ahead and double-click on that to add it. A Collision Shape 3D is a lot like a mesh instance. We need to give a collision shape a resource. It's giving us a little warning to tell us this, by the way. If I click on the little warning, it tells me a shape must be provided for a collision shape 3D to function. Please create a shape resource for it. What it's telling me is, just like with the mesh node that we just added a moment ago, it needs to know what actual polygons, what type of a mesh to have. Our collision shape needs to know what shape of a force field and the size of the force field this object should have. So if I select that collision shape 3D and go over to the inspector on the right side of the Godot editor, it has a shape property, its first property over here. It's empty, so I'm going to click on the little downward arrow and pick a box shape 3D as its shape. If I select a new box shape 3D and click to confirm, you can see that it made that same size of, I think it's 2 by 2 by 2 for the collision shape size. How do I change the size of this one? Well, like with the mesh, I can click on the box shape to expand its properties, or I can click to collapse that section as well. I can type values directly in, but I can also, in this case, because it's a collision shape, grab these little pink handles and stretch out, hopefully you can see what I'm doing here, stretch out that collision shape so it's approximately the right size, 10 meters across, and then I can go up here to its size and just type in manually 10 and press enter to confirm that. I'll do the same thing with the z-axis as well. I'll drag that little pink handle and then just change it to 10 and press enter. And it's still too tall, so I'll make it a little bit shorter, but then type in 0.5 and press enter to make it exactly the same size as the mesh. I can go ahead and hide the mesh to just see the collision shape, and hopefully if I show and hide it, I can see that they're exactly the same size and in the exact same position. By the way, if you accidentally move your collision shape up or your mesh in some weird position,
Give 6 times longer lasting freshness plus odor protection with Downy Unstoppables. Try for under $5.
you can always select that node, go to the transform section of the properties in the inspector, and reset the position to 0 and 0 and 0 to reset it back to the very middle of your scene. Okay, so now we've constructed a floor for a 3D game level. How do I actually move my entire floor all at the same time? Because right now, if I select the floor over here in the scene dock and I use my little move tool, by the way, if I have my arrow tool selected, it'll give me all of the options for moving and rotating my selected object. I'm going to press Ctrl Z to undo that move. If you have the move tool selected, you only have move or rotate or scale, depending on which tool you select. That will be the only one that's available for you, but the arrow tool is a good one to stick with most of the time. If I select the floor, the root node of the floor object, in other words, the static body 2D, and I move it, well, you could move the floor this way, but I'm going to warn you to actually do one little step before you try moving your floor around. I'll press Control Z on my keyboard to put it back at 000 in my world. What you'll want to do here to make sure that you don't accidentally select just the mesh and move just the mesh around and then have to move the collision shape separately. But even when you do that, well, if you select the floor, you'll notice the floor still thinks it's at 000 in your world. To avoid all this headache, what you can do is I'll press Control Z a few times to put everything back to the middle of my world at 000. What you'll want to do is group your floor together. And what that means is if you select your floor and press, it's right here, this little icon on your screen on the top bar, it looks like a little piece of abstract art. If you press this button, this is called the Group Selected Nodes button, and it makes sure that selected nodes children are not selectable. So if I select the floor and I press that button, you'll see that same little icon show up right next to the floor. It means that it's grouped with its children. And that means if you simply click in your 3D editor on that object, it will not select the children of the floor, it'll select the floor itself, and then let you move the floor however you want, okay? So if I move my floor down just a little bit, in fact, what I'll do is I'm going to press the Z button up here in this gizmo that's on screen that shows me which directions I can see my scene from. If I click on the little Z button, it'll take me straight to my rear orthogonal view. But if I click on that button again, it'll take me to my front view. What I'm going to do is move my floor up so that the top of the floor matches where the red line is, where that grid is in my scene. I want the floor to just meet up with that. So that's going to be the floor in my game level, okay? Let's go ahead and do a save. I'll press Control S on my keyboard. How does my game level look when I'm playing it? Well, if I select my level 1 tab up here, and I press the Play Scene button up here, it'll play the currently active scene with the active tab. It'll play that scene when you press the Play Scene button, and here it is. It looks very dull, but at least we can see our game floor through our camera. And if you need to move the camera, there's the camera, back or up or rotate it, you can do that to see your whole floor. Why does it look so, well, gray? Well, our scene actually doesn't have any environment in it right now. We can see an environment, this nice, well, sort of nice sky and horizon and lighting in our editor. However, it's just showing a preview of what a sky and a light setup might look like. If I turn off these two buttons, it turns off the environment and then it turns off the simulated default lighting, you can see what the game level actually looks like. To add our own light, just a simple light for now, into the game level, I'll select my level 1 node here, the root node of my scene, and I'll press plus. What I'm going to do here is find a light for my scene. Where is that? Well, it's under Node 3D, it's under Visual Instance, and I believe it is called, where is it? Light 3D, and I'm going to add a type of light called a directional light 3D. If you just search for direct like that, you'll find it, and I can double click on it. It'll add a light as a child, a direct child of level 1. What this light will do is if I move it up and rotate it to point sort of downward, but maybe diagonally downward, is it'll light our entire world with a nice kind of even sunlight that reaches every corner of my game world all at once. It's kind of nice. So if I drag this light object up, if I select it and then move it straight up, you can see it looks like a sun. And if I rotate it to point downwards, maybe not perfectly downwards, maybe I'll rotate it a little bit on a couple directions to make it a nice diagonal light like that. In fact, I'm going to make it so that it kind of points away from the camera in my game level, so that when my camera looks at my scene, the light will be shining on the front of the objects from where the camera can see the objects, so the objects don't look like they're in shadows. So what I'll do here is I'll drag the light up and over a little bit, just so it has a little bit of a top perspective as we're looking at it. Great. Let's go ahead and do a Control S to save, and I'll go ahead and press Play Scene, see how our scene looks now, and now you can see we have some even lighting in our environment. To make some objects in this game level besides our ground, we're actually going to do something a little bit different here. You've seen in the first part of this video how we construct a 3D physical object in a game level. We've made our floor. When you make a physical object in Godot, usually it's made out of 3 different nodes that you make into a little structure exactly as we have here. The first node is often the physical type of object that object exists as in your scene. In this case, we made our floor a static body 3D. Your static body, though, doesn't know what it looks like. So another node that makes up your object should be how that type of object looks. In this case, a mesh instance of a stretched out cube. Lastly, the physics object, in this case the static body 3D, needs to know its collision bounds. And for that, we add a collision shape 3D. So we have a nice little set of 3 nodes, 1 parent, 2 children to make an object. However, if we make all objects like this in our level 1, like if I were to make a falling block and I made a physical object with a mesh and a collision shape, we could do that and build it in such a way that it actually falls with gravity right in this scene. However, if I want to take that same block object and add it into different levels, well, that would be trickier. So what you actually do in Godot is you make every object that you want to reuse across different levels as their own separate scene to begin with. So to make a falling block object, we're going to go up this row of tabs where we created our first scene in the last lesson. I'm going to press this new plus to add a new empty scene that's just going to be a block object that's reusable. If I go back to level 1, of course I can still be in this scene and work on it, but now I can switch scenes just like tabs in a web browser. To make a falling block, we're not going to start off this scene with one of these default options. We're going to create our falling block right away by pressing this plus and adding a type of physical object we want the object to start with. In this case, if I clear out my last search, the type of node that a falling block is going to be one of those physics type of objects. If I go under node 3D and then under, if I can move my mouse to get this prompt out of the way, if I go under collision object 3D and then physics body 3D, it turns out that unlike a static body 3D, which do not fall with gravity on their own, that there is a type of node called a rigid body 3D. And if I read the description of this very quickly, down here if I select it, I can read a physics body which is moved by 3D physics simulation, useful for objects that have gravity and can be pushed by other objects. And that's exactly what I want. So I'm going to select rigid body 3D. You can search for rigid and find it pretty easily like that. I'll go ahead and double click. And that node, not a node 3D like we started off our level with, should be the root node. So rigid body is the root node of this new scene, not a node 3D. To make our rigid body actually look like something, I'm going to select the root node here, and just like with our floor, I'm going to press plus, and I'm going to add a mesh instance 3D, which I have down here in my recent lists here, so I can just double click right there to add a mesh. I don't have to search for it or find it in that node tree anymore. It's in my recents list, which is nice. So I can select that mesh instance 3D. I can go over to the inspector. I can make it have a mesh. I'll add a default. Ooh, let's add a cube mesh, which is right here called box mesh. And once I add that, you'll see what it looks like. If I turn on that fake or temporary lighting and environment, you'll see how it would look in a more proper level. But again, we don't have any lighting or any cameras in the scene at all, and we won't, okay? So now I need to go back to my rigid body 3D and add one more thing. It has that same warning from before. It needs a collision shape 3D in order to work properly. So I'm going to select the root node, I'll press plus. I'm going to go to my recents list here and select a collision shape 3D and double click on it just like that. It has a warning, of course, the exact same as just a few minutes ago. We need to give it a shape, and so I'll select it. I'll go over to the shape property in the inspector, and I'll give it a new box shape 3D collision shape, just like that. And because I didn't change the shape of my mesh, my default cube mesh, and I'm not changing the shape of my collision shape, it will just work. They're the same exact size by default. Isn't that handy? That's it. I think we're good. If I save this scene, it's not saved right now. I'll press Control S on my keyboard. I can save this as rigid body 3D. No. I'm going to press cancel. It's a good habit to get into to name your objects, the root node of the objects to start. I'm going to call this block with a capital B, and I'll press enter. There we go. If I now save this scene, Control S, Godot is smart enough to recommend the name that you give the root node in the scene to the actual scene file, which ends with .tscm. So block.tscm, great, it's in my res project folder, which is actually my project folder, and I'll just press save without changing anything. So now I have a block scene, and it's a rigid body object, which should fall with gravity, but it's not in my level. How do I get this scene into this scene? Well, what you do is you simply select the root node of your scene to add an object to it, but instead of going up to plus to add new, fresh default nodes, what you do is you select the root node and then you press the link button. This link button is called instantiate child scene. If I press the link button, it'll let me choose what other scene I want to make an instance of in my current level 1 scene. In this case, I will select block.tscm. Please never ever take your current scene and add an instance of itself into itself. You don't want to do that, so I'll select block, not itself, and with block selected, I'll press open, and now I have that falling block in my game level. Of course, I can move it up. You'll notice that I didn't have to press in my block scene that group button like I did for the floor, because this block is its own scene, and I saved it as its own scene, and now I'm making an instance of the block in my level 1 scene. I don't have to press that group together button because scenes automatically group themselves together and make instances of them in another scene, okay? You might also notice a special little icon next to the block over here in the scene dock. This little icon shows you that this is an instance of a different scene. And if I didn't have the block scene open, if I close this tab up here, what I could always do if I want to edit the block ever is I can press this little button and it'll jump over back into the original scene where I can make changes, save those changes, Control S, and then go back to level 1, and it will affect all of the instances of this block in all of my game levels simply by editing the original one again. So changes you make in one scene will propagate out to all of the instances of that scene in all of your game levels. So now I can take the block, I can move it up, and maybe I'll rotate it a little bit just to see what happens. If I go ahead and press Control S to save, and then I'll go ahead and press play scene.
Untie, the #1 brand used by dermatologists. No irritating residues, no dyes, no perfumes.
Pizza, pizza.
Walk in for all your favorites during Little Caesar's Summer of Hot and Ready, like a thin crust pepperoni pizza for $7.99. No need to order ahead, just get here ASAP. Stuck the landing. Walk in for your hot and ready favorites like $7.99 thin crust.
Aha, we can see it falls and kind of tumbles a little bit. Now, you'll notice that our light does not have, or it's not casting any shadows, which makes things hard to see. So I'm going to fix that. I'm going to select that directional light 3D, and over in the inspector, if I go to the shadow section of the properties, I can enable shadows to be on. And now we see a shadow being cast by the cube on the floor, and that will look especially good when I save, Control S, and press play scene again, because now I'll see a shadow underneath the block, and it'll land, and that'll look great. Can I make more blocks or more instances of that same block in my level? Of course I can. If I select this block, I can simply right-click on it and say duplicate. But before I do that, what I might do is change this block instance's name to block 1, and then if I duplicate it, Godot is smart enough to name the next one block 2. Isn't that nice? If I move this block up, maybe I'll move it over a little bit, maybe I'll rotate it. I now have 2 blocks that might interact in interesting ways. Then move that one over like that and move it a little bit up. Let's go and press play scene to see what this looks like. Hey, look at that. Some tumbling blocks. What I'll do is take both blocks. If I hold shift, I can grab multiple blocks there. I'll duplicate them both at the same time. I'll then move them both up, block 3 and 4. I'll rotate them, and let's go ahead and save, Control S, and I'll press play scene. And now we have some nice falling blocks. There we go. Okay, so in this lesson we have learned how to construct 3D physical objects in our 3D environment for our game level. We've learned how to construct a floor starting with a static body 3D object, as well as using a simple 3D mesh object and a collision shape. In doing so, we learned about the inspector and different properties of each type of object in the inspector, including how to make a resource like a primitive mesh or a primitive collision shape or a collision shape 3D. And in this lesson, we learned how to make reusable objects in their own scenes by making the entire object as we normally would in a different scene. You can then reuse that object and make instances of it in different game levels. And if you update or change the original scene and save it and go back to anywhere there's an instance of that type of object, it will make changes to that object there. I'll quickly do a demo of this. If I go back to my block scene, take the mesh instance, go to its mesh and expand out its mesh resources properties. If I change the mesh to be only 0.5 meters tall, and then I change the collision shape to also be, I'll expand out the box shape resources properties here, and I'll type in the same 0.5 meters on the y-axis. Now that block is half as tall. If I save this scene, Control S, when I go back to my level 1 scene, you can see that now all of the blocks have been updated to be that same exact size and shape. And I press play scene. Now all of those new blocks fall in a different way. Okay? That will be it for this one though. Thank you so much for watching. I'll see you in the next one. Bye-bye.
When the sawdust settles and the engine roars, the thing you care about is a job well done. But when you get your tools from Harbor Freight, something about the job feels different. Your wallet. Whatever you do it for less at Harbor Freight.
Alright, in this lesson we're going to be adding a character object into our game level, and for the first time in this lesson we're going to be adding some code, a script file, onto our game character object so that the player can control the game character object using arrow keys and the spacebar on the keyboard to make the little character move in the game level forward and back and left and right with the arrow keys, as well as jump with the spacebar. So in this lesson, for the first time, you're going to see a little bit of GDScript, Godot's native scripting language, which allows you to code your game as you want. Let's go ahead and jump in. The first thing we'll do is, just like in the last lesson in this course, where we constructed our falling block objects as different scenes, and then we made instances of those scenes in our level 1 game scene, is we're going to make our game character as a reusable object in a separate scene. So to do that, I'll go up to the top bar here and press this little plus. So we're making a new empty scene. And when you make a new empty scene that will be an object and not a whole game level, you never ever start that scene with one of these default options here. You're going to start the object in the scene. The root node of it is going to be the type of physical object you want that type of object to be. So I'm going to press the plus up here instead, and I'm going to find the type of node that will make a physical character object. That type of object is under node 3D, which is pretty common because we're making a 3D game, and it is under collision object, this branch here, and under the branch called physics body 3D, we're going to find the type of physics object that you can use to code movement on, and that is called a character body 3D. So if you want to search for this up top, you can just type in CHAR for char, and you'll find it. It's the red one, not the blue one, character body 2D. I'll go ahead and double click on that, and that should be the first node that we've added into this scene tree, making the root node. This is my character, but of course we can't see it yet until we add another child node, a mesh instance 3D. So I'm going to select this root node, I'm going to press the plus to add a new node, and I'm going to use one of my recent nodes here called mesh instance 3D, which we used a few times for the floor as well as for the falling blocks. In the last lesson in this course, we used this mesh instance 3D a few times. You can of course search for it, but here it is, mesh instance 3D. We'll go ahead and double click. When I've added a mesh instance, it does not look like anything, of course, until I select it and go over to the inspector, where I can give it a new mesh resource. Of course, I can click on this little arrow here and choose the type of shape that I want this character to be. for now, we're just going to make this character a cube, because a cube is easy to tell which direction it's facing, if it's turning or not. If we use something like a cylinder, well, you can't really tell if a cylinder is spinning or turning and looking left and right, so a cube is good for now. I'll select a box mesh, just like that. There is the character's mesh. It's simple. If you want to see it with lighting, we can turn on our environment and our simulated temporary lighting, just like that. We need to make sure that this warning goes away. So if I click on the warning, it says this node has no shape, so it can't collide or interact with other objects. Consider adding a collision shape 3D or collision polygon 3D as a child to define its shape. What it's telling us to do, of course, is to select the node again and give it another child besides the mesh. The mesh is, again, not enough to give this physical object boundaries or a collision force field, if you will. You need to select the character body 3D and add to it a collision shape 3D. You can, of course, search for it or use it from your recents if you have it listed down here. I'm going to go ahead and just double click on it in my recents to add it into my node tree here. It should be a direct child of your character body 3D, not a child of the mesh like that. That's wrong, so I'll drag it onto the character body 3D to reparent it to the character body 3D, just like that. It has a warning though. If I click on the warning, it says a shape must be provided for a collision shape 3D to function. Please create a shape resource for it. What it's telling me is that I have to select that collision shape and actually tell it what shape the force field should be. So I'll go over to the shape property with the collision shape selected, and I'll give the collision shape 3D a shape resource. I'm going to use that same box shape, which will match the exact same size as the default cube size. If I go ahead and hide that mesh instance 3D by clicking on the little eyeball, you'll see that the force field, the collision shape, is the same size as the box, which is exactly what we want. I'm going to give my character a name. My character, I can double click on the root node's name. I'm going to name my character Steve. Steve with a capital S in my case. You can name your character whatever you want. I would recommend that you do not put any spaces or special characters, no dashes or dollar signs, just one word, no spaces. Make it simple. It'll make your life easier later on. Trust me on that one. If I go ahead and save now, Control S, I'm saving this scene as a TSCN file, and it'll auto-name the same name as my root node, but in all lowercase, and that's fine. It's saving it into my project folder. I'll press save. There we go. I'm done this scene. If I go back to level 1, I can add Steve into this level by selecting the root node, so your character gets added as a child of the root node and not a child of some other object in your scene. So I'll select that root node. I'm going to press the link button, and then I'll select the scene that I want to make an instance of in level 1, which is what that link button does. It's called the instantiate other scene button. I can't quite recall what it's called. I'm going to select that Steve scene and press open, and now we have an instance of Steve in the level. If I move Steve up, move him over a little bit, you're going to see what happens pretty quick. Just a note, before we run this game, I'm going to organize my scene tree a little bit better. I have all 4 of these blocks. If you added more than 4, then you're going to start to have a cluttered scene tree here. What I'm going to recommend that you do is you put all of the following blocks into a folder of sorts. If I select the root node of my scene, this root node is called a node 3D. That's the type of node that it is. And a node 3D is essentially just a container for 3D objects in your world. Well, it turns out you can use these just like a folder, which you can then collapse, just like that. What we'll do here is, if I select level 1 and press plus, I'm going to add another node 3D. I'll just search for it up at the top, node, and then I'll select node 3D and double click. I'm going to name this node blocks, and I'll press enter. And what I can do is select all of these blocks. So I'll hold shift after I select the first one, and select the last one with shift held down on my keyboard, and then I can drag all 4 blocks over top of this blocks folder and let go. And now we have a new little branch of this overall scene tree, and I can collapse blocks and expand it to see them all. Okay, that's a little trick to keep your node scene tree organized. You can also drag items around. So if I want Steve to be on the bottom, I can just drag him right below, not onto the folder, but just below it. There we go. What happens if I save and run this? I will press Control S to save. I will make sure my level 1 scene tab is the active tab with the blue line. That makes sure that when you press the play scene button, it actually plays this scene. And now you can see I have my little Steve character in my game level. It's off to the side so the blocks did not fall on him. That's a good thing. But I'm pressing the arrow keys and the space bar on my keyboard and nothing is happening. Why not? Because in order for you to add interactivity into your game, you need to add some code. You need to program your game. How do you do that? Well, if I go back to my Steve character, there's a little button right here. I don't want you to press it quite yet, but this button adds a script, a code file where you can do programming in GDScript, which you can add to any object in your game. Now, we could add a script file with code onto this Steve. However, this is just one instance of Steve in this level. What I should do instead is, and this is a good habit, is go over to my original Steve scene. If you don't have that open, you can simply click on the little clapboard scene icon next to Steve to open it up again. And we're going to select the root node of Steve in his own scene. And I'm going to now press the Add Script button.
At Acme, a team of experts, from farmers to delivery drivers and the associates in your local store, work day and night to perfect the art of fresh. Sincerely, Acme. Shop fresh food at your local store.
By clicking on it, just like that. Okay? This little pop-up will appear. It says attach node script. This is going to make a new code file called steve.gd. The language is GDScript. That's good. That's what we'll be using in this course. This code file is going to be able to inherit the functionality of what Godot has built in to all character body physics objects. Character body physics objects, like Steve, have certain methods and variables that you can use to make them move and behave like you want. Trust me, you don't want to change this default line. It's great. Make sure it is that. If you don't have that, click on the wrong thing before you press Add Script. The template we're going to use is one that's going to give us code for character movement without doing any work at all. We're not going to keep this code exactly the way that it is, but if you were to add just an empty piece of script, you would have to code it all from scratch. We're going to start off by using the Character Body 3D basic movement code that Godot gives you off the bat. We're not going to change anything here, in fact. We're just going to press Create. When we do that, Godot makes a script file and attaches it to that root node of Steve. You can see right here there's a little script icon, and you can also see that we've jumped from our 3D workspace over now for the first time into our script workspace. If you're here, don't worry, you can always get back to 3D mode just like that. If you want to see your script, you can click on Steve's little script icon, or simply head yourself back over to the script workspace by clicking the button up at the top. This code file has many lines of code. We're talking about 31 lines of code, including spaces. Now, if you've never seen any code before, this is going to be very overwhelming and you're going to have no idea what's happening. That's okay. Over the next 2 or 3 lessons in this course, we're going to cover the essentials of what you need to know about programming in GDScript to be specific, and then we'll start customizing this code and making it exactly what we want to be for the behavior of our Steve character that we want. For now, all we have to do is save. I'm going to press Control S to save Steve's scene. If I go back to the 3D workspace, we now have that script file on this Steve, which now means that on level 1, Steve also has the code file, because when you edit in any way the original scene, all the instances of that type of object at that scene will get that same change. So now our game character in our level has that script file. If I select my level 1 scene tab to make it active, and I press the play scene button, well, hey, you'll notice that Steve fell and landed on the ground. If I press the up arrow key, you can see that Steve moves forward. The down arrow key makes him move back to the right and to the left. The lighting is not really good here, and everything has the same default gray material on it. That's okay. Can Steve jump? Yes, Steve can jump with the space bar. Now, if your camera is not pointed in the correct direction, in other words, I have my camera here pointing towards the negative Z axis direction, because if I look up here at my little axes gizmo, you can see that the little Z, which points in the positive direction, is pointing to the right,
and the blue orb, little ball here, without a Z is pointing to the left. That's the negative Z direction. You can see my little camera is pointing in that same negative Z direction. If your camera is not pointing that same direction, well, when you play your scene, you might press right or left and it might move your character, well, not in the direction on screen that you see. Don't worry about it. We're going to address that as this course moves forward, but you should be able to press all 4 keys and make the little character move and the space bar to jump. So I'm going to leave this lesson here as it is. I'm going to go back to Steve's scene so you can see how I constructed my game character. It's very simple, and if I go back to my script file, by clicking on the little icon here, you'll see all of my code right here. Almost all of it anyways. And I'll leave this lesson right here. Thanks so much for watching. I'll see you in the next one. Bye-bye.